UST 2015. So we have 10 presentation, 10 papers accepted. So today we will have 5 papers, and tomorrow 5 other presentations. So we will begin in a few seconds. Just before, we will thank the LAM Research Corporation for his sponsoring. You know, he sponsors IWST and give a prize for the 3 best papers. Okay, the 3 best papers will be announced during the social event. So for now, let's do the presentation. Thanks for the LAM. Thank you. Alexandre?
Hi. Hi. So I'm going to show like a bit of the work we've been doing with Rosario. Rosario, she's an undergrad student at the University of Chile, so unfortunately she couldn't come like today, but I hope next year she will be here. So we've been working on debugging. So we show you like why we have been working on that and what are the research we've been taking so far. So I've been programming for a while, and when I was programming at the university, so this is the debugger we've been using. So you know, this is a graphical user interface of GDB, which is a debugger for C, and here you have the C code, you know, like this main with, you know this one. And here you have like, you know, things about the files and things about some variables, and here you have the local variables, and you have the stack somewhere. Yeah, somewhere you have the stack. Yeah, probably somewhere. And okay, so that was back in, you know, the previous century. And this is what debugger looks like today. So I took the screenshot like this morning. And yeah, so you know, there's a bit less color here, but this debugger actually I think is much better than the one I had when I was learning how to program. You know, I had some nice here debugging operation which are roughly the same that I had when I was a student. And here I had the method call stack, and here I had you know, the set of variables that are currently active in the frame where I am. Yeah, there are new things here I can do, such as clicking on one variables, and then I can dive into those graph of objects, and this is something that the GT Inspector offers. But essentially, like the same kind of operation is there. And if I want to be a bit bold, I would say that, you know, debugging is one of the few fields that hasn't seen any major, you know, changes for the last 20 or 30 years, and this is true. So there are a number of reasons for that. The thing is, doing research in debugging is really hard. It's really hard because you know, you have all these technical things that, you know, really technical aspect that you need to, you know, to be careful with. And this is a problem that we identify and we feel it strongly, but this is, I mean, we're not the only one to feel that debuggers need to be improved. So here, this is one of the things that I like very much. So this is called omniscient debugging. So it has been proposed by Adrian Linard in 2008. And omniscient debugging is about keeping track of the evolution of objects. So you have objects that lives, you know, they get born one day, and maybe one day they will die, and then they receive messages, and then you can always go back in time of that object. And this is something that I'm highly convinced of, you know, of its usefulness. But this is an experiment that has been made, you know, at the time, and it hasn't been like, you know, it didn't really go into the main tool that we are using today. Another very interesting, I think, work that has been done in 2012. This is object-centric debugging, and the idea is that instead of focusing on the method call stack as all the debugger do, in object-centric debugging, then you have some particular operation that focus on the object. Oh, I want to proceed until that object receives a message. Or I want to proceed until a particular message is being sent, or when an object is being provided as an argument. So this is something like very, you know, very powerful and very useful. I think also this is one of the motivation of the work that Marcus has shown this morning. So our proposal, I mean, not only what we have in the paper, but our, you know, our path is that following equation, where here we take omniscient debugging, and we add a bit of object-centric debugging, and then we add, you know, bit of Russell, and then we can be based on top of the GT tool. GT tool contains the GT debugger, which is an extensible debugging framework. And okay, and here, like a screenshot of what we have done. So here, this is the normal debugger, except here we have that window here, that pane here that contains the Russell visualization. So this is really the difference between raw debugger and the one we have, the standard debugger we have. And while the debugging session is going on, then you have the visualization that shows things happening while the program is being executed. So what happens is those kind of debugging operations, such as step over, step into, are connected. They trigger some actions that, and the visualization react to it. So I will just give a demo now. Okay, so here this is what looks like a simple iteration. So here I can debug it, and this is the normal debugger. This is the normal debugger. So here I can dive into it, dive again, and I can do step again. So here I am in some part of the compilation process, which is very complex. At that point, I can switch to one debugger we have done, which is a side effect visual debugger. So this is the debugger that is described in the paper. So here this is the same debugger, except here I have the panels. And then I can do the step over. So here I click on that, and each step over operation, then I have a new square here that happens, that shows. So here this is, I'm currently tracing the execution of the methods on the compiler. So the current object is an instance of the class compiler, which is that object. The compiler has 9 instance variables, which is here those little square, and each variables, so here I have source string that has the value nil, and so on. And then while I'm tracing the execution of the program, then I have new visual representation of the object that shows up. So here I have one that is red. It means that the value of that variable has changed. So the last step over operation triggered a side effect, and this is what here this debugger is showing. So here before the class value was nil, and when I press step over, here is no points to undefined object. Why undefined object? Because here there is method class. The current object is an instance is nil, which is an instance of the class undefined object. And then here I can keep going, and here again I have source string. Now I have a read string into it, and source string. So it was nil before, and then the variable source string no points to the string read that contains the source code of the thing. And then we can go on. And again here I have this parser, the parser has been created. Does it make sense? Do you understand? So this is like a very simple, example. Another example that here I would like to show you is so another debugger we have done is this one here. So let's pick a random execution, absolutely random execution from, let's say, Molina. And here I click here, and this is a piece of code which I can execute that things, and right click on that. I can right click here, I can select that, and shortcut to open the debugger. So now this piece of code will be executed within the debugger here. So I can execute the first statement, and now here I can switch to a different debugger, which is reaction debugger. And again, here this is a debugger with here a visualization, currently is empty. But I can add object to it. So let's say I want to add current object, which is B, which is just created. So this is an object that contains, many variables here. So what I can do is expand all. So I can expand the object. Force layout here. So here I have the RT boundary that points to boundary and frame and points to an edge builder. And as soon as I'm executing the code, then when there is a side effect that happens here, the side effect will be shown here. I think something will happen, yeah. So by doing the B nodes at the object with all the classes, that's a side effect on that object. Yeah, I don't think there is more side effect here on that. Yeah, so that was for the demo part. Okay, so that was the example I've just shown. So the idea here, we can customize a visualization that presents, that reacts to the bottom here. So how is it done? This is very, very simple way. So we define a small framework, very easy to use. So here, this is a class that we provide. When you want to create a new debugger, a new visual debugger, you just need to create a subclass of that class. In that case, this is a side effect debugger. And also we need to have a debugging session. Just need to create a subclass of it. So this is this object. The next one of that class that we contains all the elements, and we do the connection between the visual, the view, and the debugger itself. And then on that class, then you need to have the variable that will keep the information for the visual representation, and then you need to do some method override. So here I have the step over. Step over, this is the method that is called when I press step over in the debugger. And that method gets called, and then you can have, code here that either record, either update the view, or whatever you feel like. And then the execution, this is something that you can easily switch to with that menu here. Also, I think there are ways to automatically switch to debugger, the right debugger according to what you are currently debugging. This is probably something we'll investigate into. Okay, so this is, the early work we wanted to show you. So the first question, is it really worth researching on this? From an academic point of view, yes, it does make sense because little work has been done on that, and since we have a fantastic machinery which is smart of Faro, then there are a lot of things we can do that nobody has done before, and therefore, from a paper point of view, we'll be able to publish that for sure. But now the question, does it really make sense to work on this? Besides the paper, the paper business, yes, it does make sense. I mean, in 2006, it has been shown, in a very famous paper, that when programmers are doing their job, they have a lot of questions, and probably you will recognize yourself, right? I mean, where is this variable or data structure being accessed? And what data can we access from this object? How are these types of objects related? So all these kind of questions that are very natural for, when you program, it has been shown in that paper that people are using debuggers to answer those questions. So, providing better tools to understand to answer those questions is absolutely crucial. And okay, so what I've just shown you, this is what we have so far. So as a future work, we like to connect the debugger to some other visualization we have done. For example, here this is a memory blueprint that we have. So this is the result of executing Rosario. This is nice, right? So here, this is Rosario. So again, we are visualizing Rosario itself. So here in A, all those objects here, this is PowerShell. B, this is Rosario. So you see a kind of very, very strong connection between PowerShell and Rosario, which is expected. And here we have the C's, here we have all the RT groups, which is a kind of super smart object collection for objects. And then here we have the E, which is all the events. So this is a very interesting visualization I think we have. And connecting this visualization to the debugger is really our next step. Okay, so this is, yeah, so thank you very much. And she's Rosario. She couldn't come, but next year I hope she will be able to come. So thank you very much.
Any question?
I remember that Adrian, I think, had to modify the VM to get his flow thingy going, like for keeping track of all the changes that happened.
Yeah, exactly. Yeah.
Why didn't you have to do that, or what do you have to do?
Because now we have, the very cool things that Marcus showed this morning. That probably there is no need to modify the VM.
And that still performs reasonably well, like in terms of speed. Yes,
and the reason is that when you do, I mean, in some situation you can afford to be slow, on execution. For example, when you press the button like step over, basically you need to provide, you need to say to the debugger, oh, please execute one instruction. So if this instruction takes a bit more time or not, doesn't matter really for you. In some situations, right? But currently, I don't know, we are still experimenting and it seems this is something interesting to pursue. Yeah.
Second question.
Have you already tried, for example, on the other developer of your team or your student or something like that, to use your visual debugger, and what is the reaction?
Okay, so we went through several iterations. So I think this is the third iteration, and we started from scratch like each time, because it was not easy to understand like what are the right things we wanted to do, and whether we use GT debugger or not. That was also one big question that occurred in iteration 2. So we went like through several iterations, and we asked like a couple of engineers and students, does it make sense to you or not? Apparently, like it seems to be something interesting to pursue. So that's why I think what we are, we're going to build on what I just shown. So it seems we have got positive feedback so far, but again, we didn't measure that accurately. Okay, so thank you very much. Thank you.
Okay, so I will present you the second paper, but I'm not the author of the paper. I'm user. So the paper has been written by those guys from Synectic and some from IDEA. And I will try to do my best to present you these two. So, according to them, and I agree with them, a visualization is different groups with some kind of layout. So here we have some groups, we have 4 groups, and with some layouts, we have some nodes, some connection between nodes. We can put some style, we can do some interaction. We can do some interaction, and we may have a legend. So they have built Telescope. And what is Telescope? It is a visualization framework that has been built on top of Rosario. So here are two examples of what can be done with Telescope. So why have they developed Telescope? Rosario is very cool, and I'm sure that you have already seen Alexandre doing a demo, and it's amazing. Everyone is, oh my god. So it's true, but when you start by yourself, it's, oh my god. So it doesn't look like so fast. So the idea is also to capitalize the expert knowledge. Alex can do very beautiful visualization, but when I want to do one, I don't want to copy paste. I want just to say, okay, this one is very good, but I want to put my data inside. That's the idea. And so for this, we have to provide high-level mechanism. And in order to capture the visualization domain, so for this, we need a stable API. I tried in the train to do the demo that Guillaume sent to me. And they were a mistake. Why? Because Rosario has been updated on Sunday. So it's really great that they do a good job, but when the API is changing, I don't want to redo every time my visualization. When there is a bug, it will be the team of Telescope to do the change, not me. That is a good point. So, if you're a newbie user, like me, for example, you don't want and you don't have time to invest to do your visualization. What you want is to visualize your data. So you will reuse predefined visualizations and eventually customize to your needs. So I will show you a demo, if it works. So the first demo is this one. So it's a tree explorer. You put here it is a class, and you can expand. And as you can see, so it's zoomable by default. And the layout is computed, like this one is computed, oops, sorry. It's computed by default. When you expand, it's computed in order that you can see everything. So that's the first one. And if you want to use it, you have only to put your data. I will show you later.
Sit down.
And the second one is So this one is a distribution map, and the legend has been computed by default. And here it's just some classes, and so each big rectangle is the classes. Inside you have the method. Each method is the color change according it is abstract or not. And you have some interaction like this, and once again it is zoomable by default, and that's it. So if we come back here, so this one was the tree explorer, and as you have seen, the layout is completely managed without doing nothing, for me, for us. And this one was the distribution. So now what we will do is we will use an existing visualization. So this one is the butterfly visualization. It means it's this. So you have a central entity, a main entity, and you have some entity on the right, for example, the one that needs this entity, and on the right, you have the one that the main entity needs. So by default, this visualization, so you just have to say that you want to do a new butterfly. What is your main entity? This one is to compute the left entity, and this one to say what has the right, and you open, and that's all. Everything, when you are a newbie user, is useless for you. Everything is done by telescope. And so now we will adapt, customize this visualization. So the first thing is we will change the shape to put ellipse and not rectangle. So it will be like this. It's what this line is doing. And now what we will do is that we will add another style sheet and that we define here, and in the other one here we are saying to which group we are applying it. So we define a new white background style, and we apply it to the left group. This is the left group, and so that is how it has been. And as you can see, all the nodes of the group have been modified. So this one is the one that I have made as a user. So here, so I have made my butterfly, my new butterfly visualization, my main entity. So it's an entity that I have taken from a model, so that's why it's a little bit difficult to find it. And after, I profit to this presentation to show you a quick overview of the new version of MoveChef. As you can see here, I query all the input associations that come to the table and so on, and to the right, all the output. And here I put the color to say that it is different. And that's the only thing that I have done. All the rest is done for me. So it was very, very quick to do it. And so I think that you can do it. If you know you are an expert developer and you think that even if there is already a lot of demo available, you want to do a lot of visualization available, you want to do your own ones. So you can create new visualization, but obviously for this purpose you need to know the model. But you don't need to know to know or to care anything about drawing, because when you draw, it's done with Rosario. You can reuse predefined action and you have high-level abstraction. So I will show you another demo. Okay, this demo, this visualization is just to show you that we have two groups. On the left, when you go on mouse over, it's red, and on the right, it is blue. And now when I click on one, it's going to the other group, and the mouse over action has changed. It was red and now it is blue. So I will explain that to you. we will just after we will build the visualization together. So what is the logic of the visualization? The visualization is a root, and it has several groups. And in fact, a visualization is a tree. And we have some nodes.